Today we will do about the reactions between metals and non-metals, or otherwise, how does the chemical reaction take place between metals and non-metals. Alright. Now let us study that we have studied it. All metals have got their valence electron less than 4. So to get the stable configuration, they tend to lose the electrons. Understood? Now let's understand how. Sodium has its atomic number 11, so atomic configuration is 281. Right? So sodium used to get the configuration neon is 280. We are studying the nights and then an atom is supposed to become stable if it gets a stable inert gas configuration. So it has to get the configuration of neon, and that configuration is obtained by losing this one electron. Understood? So when sodium loses one electron, then it becomes Na plus. When it is lost, so you know that it has got 11 protons and 11 electrons. And when one electron is lost, then it has got 11 protons and 10 electrons. That makes it charge 1 plus. So for a long time back I told you, an atom gets selectively charged only by electrons. If an atom loses electron, the number of electrons becomes less, therefore it becomes positively charged. Likewise, if an atom gains electron, the number of electrons become more, therefore it becomes negatively charged. So sodium loses its one electron and it forms Na plus ion. It is Na plus. Understood? Now, let's take another is chlorine. Its atomic number is 17, electronic configuration is 2s7. The chlorine needs to get the configuration of argon. Argon has the configuration 2w. So what takes place is the sodium which has losses one electron, and that one electron is chlorine takes. Understood? So when the chlorine meets at one electron, as you know that chlorine has got 17 protons, now it has become 18 electrons, so that makes it minus 1. Understood? So sodium is transferring its electron to chlorine. This is what is most important. One arrow depletes one electron is given. It is given to chlorine forever. So it becomes, when it is transferred, it is positively charged, it is negatively charged. And you know the opposite charges will be attracted. So this force of attraction between Na plus Cl minus is known as ionic bond. Ionic bond, or it is also known as electroviolent bond. Understood it well? Ionic bond, that is, a chemical bond is defined as a force of attraction between ions. Chemical bond is defined as force of attraction between atoms of a molecule. Lower classes you are studying. Atoms cannot exist independently, so atoms will be combined to form the molecules. And if a molecule is there, you can understand among the atoms there will be a force of attraction, and that force of attraction is known as bond. So here we have the bond or the force of attraction between positively charged ions and the negatively charged ions is known as ionic bond. This Na plus, which is positively charged, is known as cathode ion, or it is in short form, it is known as cations. Now you can understand it, you can remember it easily. You know that during electrolysis, we have two electrodes. One is cathode and another is anode. You know it. The cathode is a negative electrode and anode is a positive electrode. So when subjected to electrolysis, opposite charges will be getting attracted. Subjected to electrolysis, opposite charges gets attracted. So what can we say that the cathode negative electrode towards which the positive ions will move, and that is why these positive ions are known as cathode ions, and Cn minus, when subject to electrolysis, this minus charge ions will move towards anode, which is a positive electrode. Therefore, that ions, such type of ions are known as anions. Cations are positively charged and anions are negatively charged. And among these signs, there will be force of attraction, and that force of attraction is known as I told earlier, ionic bond or electroviolet bond. Ionic bond or electroviolet bond. So remember the definition of bond. Bond is a force of attraction between the atoms of a molecule. Now, why should a molecule be necessary? That also you must understand it. Because atoms are unstable. Atoms combine to form the molecules. Atoms combine to form the molecules. Therefore, When a molecule is formed, among the participating atoms there will be force of attraction, and that force of attraction is what we call it as bond. And the bond between ions is known as ionic. Understood it clearly? Now, normally this is suppose like this thing take place during the formation of ionic bond. As I'll say that because an atom has to gain electron for which another has to use it. So first thing that has to take place in the formation of ionic bond is cation formation. When the cation formation takes place, then only the anion formation can take place, isn't it? Somebody has to use electron. The first thing in ionic bond formation is losing of the electron. And once the electron is lost, the other one can gain it. So first thing as far as ionic bond is concerned, the losing of electrons by an atom. And likewise the other one gains it. Now, an atom has to lose electron, as we discussed earlier, it needs energy. So when it gets some amount of energy, then only it will be loose. So with how much amount of energy an atom is going to lose electron, and that is one factor which determines the formation of ion. Understood it clearly? If the atom requires very large amount of energy to lose electron, then the formation of ionic bond will be slower. Have you understood it clearly? All metals have a tendency to lose electron. But how fast an atom is going to lose? Say, for example, let's take it like this situation. The formation of sodium chloride and the formation of potassium chloride. Sodium chloride, the electron is transferred to the chlorine, and potassium, the electron is transferred to the chlorine. Understood it? Now, if your question is asked, which of these two formation will be faster? Now, let us understand. When we talk about the sodium, both the cases the bond is ionic bond. Sodium's electronic configuration is 281, that is to the nucleus, and potassium's is 281, so to the nucleus. So what has happened? The valence electron of potassium is much far away from the nucleus. So the nucleus has the least amount of force of attraction to the valence electron. So potassium can lose its electron much more easily than in the case of sodium. So we can say that the formation of potassium chloride is much faster and easier in comparison with that of the sodium. Understood it clearly? Similarly, potassium fluoride and potassium chloride. Potassium chloride is given one electron is to be lost, fluorine 27 and 287. So both pairs have one electron. Now potassium is transferring this electron, here also is transferring. But this one, as far as chlorine is concerned, the nucleus, the valence shell is away from the nucleus. So the nucleus exerts lesser force of attraction to the valence electron, whereas fluorine can attract the electron with much force or much easily. Therefore, formation of potassium chloride is faster than that of potassium chloride. So, the formation of ionic bond is determined by how well an atom loses electron and how well an atom gains. The first thing that takes place is the losing of an electron, that is the formation of an cation, and then the formation of anion. In this case, ionic bond is formed. Ionic bond is also known as electroviolet. Now let's take further more. If you want to study about the formation of magnesium chloride or magnesium oxide, etc. Magnesium, you know that atomic number is 12, it has got two valence electrons, 2, 8, 2. So these are the two valence electrons. And if it has to react with oxygen, oxygen's atomic number is, you know that 6 electrons are there in the valence, 6 electronic number is 2, 6. All those orbits which are completed, what we need not show. We are showing the valence shell, that is our most. So what happens? These 2 electrons of magnesium is transferred to the oxygen. Now remember, if you show only this line, that will be marked wrong. The transfer is shown by the so magnesium transfers its electron to one oxygen, it is transferring to the next same oxygen. And this is the magnesium oxide formation. Now let's take magnesium chloride. Magnesium has got 2 electrons and chlorine is having 2, 4, 6, 7 electrons. 3 plus 7 electrons over there, and the next chlorine is also 7. So the what happens? This electron is transferred to this one, and this electron is transferred. So how many electrons are transferred? That is, don't show one arrow and say that 2 electrons are transferred. One arrow represents only 1 electron. Say 3 electrons. Say for example, aluminum chloride. Aluminum has got 2, 3. It has got 3 valence electrons. So this is to be transferred to the chlorine, this is to be transferred to the chlorine, this is to be transferred to the chlorine, therefore aluminum chloride is AlCl3. This is how the bonding is taken. Concept is clear? Ionic bond or electrovalent bond. Remember, the force of attraction will be when aluminum loses its electron, it becomes K+. And the chlorine is, each one is having 1 minus charge. So the molecular formula of aluminum is AlCl3 and all compounds are not relevant because aluminum has got 3 plus charge and P chlorine will be having 1 each, making it -3. So the total charge becomes 0. Understood about ionic bond? Okay. Now the next one is the properties. Properties of ionic compounds. Now let's say sodium chloride. Na transfer its electron to chlorine, so it is Na plus Cl. Understood it? So this sodium chloride is will be always having Na plus Cl minus, Na plus Cl minus, Cl minus Na plus Cl minus Na plus. So what has happened? If you take a crystal of sodium chloride, it will be having number of Na pluses and Cl minuses. Understood? One molecule does not form a material to be seen. So if you take a small piece of sodium chloride, it will be having thousands of Na plus and Cl minus. Among all these Na plus, don't just think that this sodium will be attracting this one. This Na is attracted by this one, Cl is attracted. So the force of attraction between the Cl minus and Na plus among all the ions present. Understood it? Remember, if you take a piece of sodium chloride, it will be having millions of Na plus and Cl minus. So among all these Na pluses and Cl minus, there will be the force of attraction. And this force of attraction will make the substance what we can say that crystalline. Ionic compounds or electrovalent compounds are crystalline solid. And what are crystalline substances? And those materials which have a constant geometrical shape. Those materials which have a constant geometrical shape are known as crystalline substances. So what can we say? Ionic compounds are crystalline. Why are they crystalline? Because the force of attraction with all these atoms and ions will make them somewhat like constant shape, constant size, and that is why they are crystalline. Understood it? So remember, sodium chloride crystals are neutral. It does not have any charge because each Na plus is neutralized by Cl minus. And among each Na plus, there will be the force of attraction exerted by the Cl minus. So don't just think that there will be attraction between one Na plus and Cl minus. It is not so. One Na plus is attracted by number of Cl minus, and one Cl minus is attracted by number of Na pluses. So that thereby the strongest force of attraction is existed over it, and that gives them crystallization. Understood clearly? And since you can understand the strongest force of attraction is between opposite charges. The strongest force of attraction is between the opposite charges. So Na plus is attracted by the Cl minus. This force is very strong. And due to the very strong force, what have I told you? There exists line solid among these things. And if this crystalline nature of the sodium chloride is to be lost, suppose, then what happens? We will do heat energy. When we heat it, what happens? The force of attraction between them is broken. They don't get easily broken. So when tremendous amount of heat energy is given, the force of attraction between them will be broken. And then what has happened? Each of these Na plus is able to move out from Cl minus. And that means, and that shape what has happened, its rigidity or the crystalline nature will be lost, and therefore the solid gets converted into liquid. So we can say that ionic compounds have a very high melting point. Why the very high melting point is generated? You understood it? Because each Na plus is being attracted by each Cl minus. So there exists the strongest force of attraction. So when the force of attraction is there, that will make them as rigid material. And when we give heat energy, the force of attraction between them is getting broken and it gets converted into liquid. And that force is to be broken, very large amount of energy is needed. That is why we say that ionic compounds are having high melting point. Understood? Generally, they have got very high melting point. The next one. Ionic compounds are soluble in water. Now, water is a polar solvent. We will study that, we have studied it. So when we do about the carbon compounds and covalent bonding, we will do that. So it is a polar bond. So water consists of H plus and minus ion. The covalent bonding structure is there. So there is slight amount of charge involved that we will do here. So these polar solvents like H2O, when NaCl is put, remember Na plus and Cl minus are staying together. And when that is put into water, what happens? We separate it into Na plus and Cl minus. Understood? So this makes sodium chloride soluble in water. Ionic compounds are generally soluble in water, and this process is known as ionization. Ionization. What is the meaning of ionization? The compound is split into its constituent ions. Understood it clearly? So sodium chloride is dissolved in water due to its ionization. Sodium chloride is split into sodium ions and chloride ion, and that process we call it as ionization. So ionic compounds are soluble in water because of ionization. Understood it? So if somebody asks the question, is there sodium chloride present in water? The water does not have sodium chloride, though we say that common people say that the water has got namak in it or common salt in it. But remember, when common salt is dissolved in water, what is common salt? Na plus and Cl. When they stay together, they are common salt. And when they are separated, they are not common salt. So water does not have common salt. Water has sodium ions and chloride ions. Understood it clearly? And that process is known as ionization. So ionic compounds are soluble in water due to ionization. Clear? The next one is ionic compounds are called electrolyte. Electrolyte. Electrolytes are compounds through which electricity can be flown either in the molten form or in the solution form. Electrolytes are compounds through which electricity can be flown either in molten form or in solution form. So what do we say that ionic compounds are good electrolyte? Now, we have studied in the previous classes a material to conduct electricity. What is needed, as I told you earlier, metals are good conductors of electricity because they are mobile or free electrons. And certain like sodium chloride is a good electrolyte because electricity to be flown, the second thing is it must be having ions. Understood it? So if you take solid sodium chloride, it will not conduct electricity. The reason is it does not have any ions. It does not have Na plus and Cl minus. Whereas when that sodium chloride is heated, it melts, and molten sodium chloride contains sodium ions and chloride ions. And if sodium chloride is put into water, it gets converted into Na plus and Cl minus. So compounds through which electricity can be passed. Remember, metals are good conductors. They are not known as electrolytes. Now, what happens to a metal when electrons are flown? Nothing happens to the metal. It remains as such. Whereas when electricity is flown through an electrolyte, what happens? It is separated into its constituents. First chapter we have studied electrolysis. The splitting of a compound into its constituents with the help of electricity is known as electrolysis. Understood? So electrolytes are compounds through which electricity can be flown. And if electricity is flown and they are dissolved, separated into its constituent ions, which we call it as electrolysis. Anyway, we understood it clearly. So there is the activity which I have been given in this one. We are taking this is solid NaCl, and I put one electron over here, one electron. This is connected by the battery supply, and then we will be attaching a bulb over there. The bulb is attached over here, and the rest is attached over there. So if the current flows through this one, the bulb goes. So what happens in that solid sodium chloride? The switch is put on, the current is flown. But what has happened? The bulb does not flow. That means the current doesn't flow through this. Now when we heat this one, as this is heated, the sodium chloride melts. And when it starts its melting, it will provide ions. And when the ions are there, then what has happened? It will conduct electricity. Likewise, if you put some amount of water, then also what happens? The sodium chloride gets converted into its sodium ions and chloride ions, then also it will conduct electricity. Understood? So ionic compounds are good electrolytes. Ionic compounds are crystalline. Ionic compounds are having high melting point. Understood it clearly? So these are the common properties, and you must know with the reason. Like during the formation of a compound, say for example, listen to this question. During the formation of a compound AB, A has transferred its valence electron, one electron to B. Identify the bond present. Transfer of electrons means ionic bond first. Understood it? And what is the physical nature of this compound AB, crystalline solid? Why it has got high melting point? So high melting point means the bond is to be broken, which needs very large amount of energy, so that make it crystalline solid, high melting point, and good electrolyte, soluble in water. Understood it clearly? These are the properties of ionic compound and how the ionic compound is formed. The next in that is these become the common properties of ionic compounds. For example, write down the electron structure of sodium and chlorine atom. How do these form a chemical bond? Name the type of bond formed. Why does the compound so formed as high melting point? Understood the question clearly? Show on diagram the transfer of electrons between atoms of formation in magnesium oxide. I have shown that earlier. Understood? Remember, the transfer is shown only by the arrow. Understood it? This is all about in that chapter. Now let me metallurgical. Let me see the syllabus. What is left? Properties of ionic compounds, metal formation and formation. So formation properties of ionic compound. Clear everybody? These things.